Hello class, welcome to homework review number 1, Regents review. So tomorrow you're going to get a quiz on this. It's going to be about, first off, just basic information from the reference table on planets. So we got our terrestrial planets versus our Jovian planets. Easy way to remember the difference between them. I always look at the word Jovian and remember J for Jovian, J for Jupiter. So Jupiter is our first Jovian planet. The rest are going to be Saturn, Neptune, and Uranus, not in that order. So this is the order right here. So those are our gas planets. They're really, really big. They have a giant equatorial diameter. Equatorial diameter just means the length of their equator. It's a complex way of saying size. The other planets are going to be our terrestrial planet. That includes Earth. And the other are 4 inner planets. So those are rocky. They're very dense, high density. And the key is to just remember, let's see if this bad boy works. Yes. The key is just to remember that the inner planets are going to be our terrestrial planets. The outer planets are our Jovian planets. So here's a really intro question. We got planet A here. We've got planet B here. Compare the planets' periods of revolution. I always like to think of the word period as like, in school we have periods, right? So 8 periods, and the period is 42 minutes long, right? So if we were to increase that period or make it a longer period of revolution or whatever, we would make it longer than 42 minutes. So in this case, we're going to compare the planets' periods of revolution. In reality, these inner planets, they go zooming around the sun or in orbit compared to these outer planets that move a lot slower. So if we were to compare these, I would just say planet A has a shorter period of revolution because it's a shorter amount of time. Period just means time, and it would look something like this. Planet A is closest to the sun, so the period of revolution would be shorter than planet B. Alright, so basic info about planets. Just remember that D is for days, so days are going to be shorter than years, and hours is H, so hours are going to be shorter than days, just like days are shorter than years. And eccentricity is always rounded to the thousandths place. We'll review that as well. You don't need to necessarily know that for tomorrow's quiz though. So 5 things you need to know. You must know about the sun. First off, the moon causes tides. We have 2 high tides a day, and those 2 high tides are caused by Earth's rotation on its axis. So if they ask you what caused the tides, it's going to be the gravity from the moon first off, and then the second one is going to be Earth's rotation, which causes the tides to appear or seem to move. You have to know how to draw the phases. I'm going to go over that. You have to know where the moon is located in its orbit to cause a solar versus a lunar eclipse. We'll go over that as well. You have to know the moon's period of revolution is equal to its period of rotation. That's why we always see the same side of the moon. And then finally, you have to know that the moon's period of revolution is only 27.3 days, while the moon, to complete a full cycle, new moon to new moon, or full moon back to full moon, it's going to be 29.5 days. This number is in the reference table for its revolution, aka its orbit, but the number you have to memorize is 29.5 days. You can just write 29. It's acceptable. 29 days is totally acceptable to go from a new moon back to a new moon. So, let's say we're going to be asked to draw a phase of the moon. First off, you find which one they're talking about. Let's say it's this one over here. Next, you're going to look on its orbit, see its orbit here, and we're just going to draw a line to connect this part of its orbit to this part of its orbit. That just separates what we can see from Earth, right? We can only see this side from Earth, and we can't see the other side from Earth. After that, I am going to turn my paper so that I am looking from the Earth up at the moon. It helps to draw a little guy there just to say, that's me. So I look up at the moon and I ask myself, which side is lit up from my perspective? Remember, I can't see anything on the other side of the moon. I can only see what's facing me. So in this case, I'd say the right side is lit up. Next, I'd say how much of it is lit up. Is it going to be half lit, where I can only see half dark and half light? Is it going to be less than half lit, or is it going to be more than half lit? In this case, it is more than half lit. So what side of the moon is lit? The left or the right side? Is it less than half lit, or more than half lit? We're more than half lit, and it's the right side. So in order for me to draw that, I'm going to shade in the dark part because it's only a little bit dark. The right side is lit, and it's more than half. Okay? That's what we're going to have right there. Information to remember, revolution means orbit. So if they ask you what's the moon's period of orbit or the moon's period of revolution, that's straight out of the reference table, 27.3 days. But if they ask you how long it goes for the moon to go from a new moon back to a new moon or complete a cycle, a phase cycle, that's the number you have to memorize, 29.5 days. And once again, you can just write 29 days. But if they ask you to the 10th place, you have to include that 0.5. All right, I don't know why that's there. So, final basic info, eclipses. So, when the moon is right here, if I'm looking from Earth, then I would not be able to see the sun. The sun is blocked. That's why we call that a solar eclipse. Now, if you were to ask me what moon phase happens during a solar eclipse, the moon is going to look completely dark. The only place it can look completely dark is when it's between us and the sun. I can only see this side of the moon from Earth. So a new moon is during a solar eclipse, because a solar eclipse is when the sun is being blocked. Opposite of that is a lunar eclipse. A lunar eclipse is going to be when the sun's light is going to be hitting the Earth, but then does not go onto the moon. It's going to shadow the moon. The Earth's shadow covers the moon. That only occurs during a full moon. I can only see the full side of the moon from the Earth. I can't see any of this dark side. So, solar eclipses occur during new moons and they block the sun. Lunar eclipses are going to occur during full moons when the Earth's shadow goes over the moon a bit. Final basic thing, highest tides and lowest low tides. So when do we have our highest high tides? That's going to be when the moon and the sun are lined up, because they both pull in the same direction. Don't forget, since we have 2 high tides a day, that means we have 2 high tide bulges. So there's going to be one on the opposite side of the moon as well on the side with the moon. So our highest high tides are going to be when the moon is a new moon and a full moon. Just like the eclipses. The eclipses happen during our highest high tides, lowest low tides, highest high tides, lowest low tides. When do we receive moderate tides or not so extreme tides? That's going to be when the sun is pulling in one direction while the moon is pulling in a different direction. So in this case, that's going to be our quarter moons, is when we have our non-extreme tides. Most likely they'll ask you information about the highest high tides or the lowest low tides. And those are our extreme tides. That's when the moon and the sun are working together. All right? How much time goes by between high tide and the next high tide? They'll usually give you a graph for this if they don't memorize it. It's 12 hours. We have 2 a day. That means every 12 hours we have to have 1, right? So 2 a day. Let's predict when the next low tide will be. So I look, there's my high tide here, my low tides. This low tide occurs about at 7:30 a.m. The next low tide is about at 8 p.m. So if we went from 7:30 to 8, the next one's going to be another 30 minutes, 8:30. But here's the deal. We went from a.m. then to p.m. When's our next one going to be? 8:30 a.m. And that's going to be somewhere off the graph, right? So that's just a prediction. What 2 factors cause tides? One is going to be the moon's gravity. They could also say the sun's gravity, but the moon is 2.2 times more effective on tides. But it's also the Earth's rotation. That's what causes the double high tide in one day. All right? Why do we always see the same side of the moon from Earth? It's a beautiful thing. It's just the fact that the moon's rotation equals the moon's period of revolution. If you look in the reference table, it's going to be in there. Moon's rotation equals the moon's revolution. If you know all this stuff for tomorrow, you will be fine for the Regents quiz that you're going to be getting. Okay, thank you.